The universe is silent, and that silence is the loudest mystery we have. We live in a cosmos filled with hundreds of billions of stars, each potentially hosting worlds, and yet our telescopes have found nothing, no signals, no signs of anyone else out there. This is the famous Fermi Paradox, the profound contradiction between the high probability of alien life and the utter lack of evidence for it. By the end of this exploration, you will understand a radical theory that solves this paradox by suggesting the most advanced beings are not gone, but sleeping. We will journey into the mind-bending Aestivation Hypothesis, an idea proposing that supreme civilizations might be in a state of cosmic hibernation, waiting patiently for the universe itself to cool down to achieve their ultimate goals. What if the greatest intelligence isn't measured by the noise it makes, but by the silence it keeps? The heart of this mystery is named after a simple question. In the 1950s, physicist Enrico Fermi, looking up at the seemingly empty sky, asked a question that has echoed through the decades: where is everybody? This is the Fermi Paradox. On one side of the equation, we have overwhelming probability. Our galaxy alone contains hundreds of billions of stars. A significant fraction of those stars have planets. Many of those planets are in the habitable zone where liquid water could exist. Life on Earth began almost as soon as it was possible, suggesting it might be a common, even inevitable, process given the right conditions. And if life is common, intelligent life with technology should have arisen many times over the billions of years the universe has existed. Some of these civilizations, even if they are exceedingly rare, would have had a colossal head start on us. They could have spread across the galaxy, building wonders, sending signals, leaving artifacts. The universe should be buzzing with activity. Yet, on the other side of the equation, we have a profound and unsettling silence. Our radio telescopes hear nothing but the natural hum of stars and gas. Our most powerful observatories see no megastructures blocking starlight, no vast fleets of spacecraft. Our own probes have found no ancient ruins on Mars or visiting probes in our solar system. It is as if we walked into the largest, most crowded party imaginable, a party that has been going on for billions of years, and found the room completely dark and silent. Everyone is hiding, or worse, no one else showed up. This contradiction between the high probability of existence and the total absence of evidence is the paradox that keeps scientists awake at night. To solve it, thinkers have proposed many possible answers, each more mind-bending than the last. Perhaps we are in a galactic zoo, carefully isolated by advanced beings who are observing us but not interfering, the so-called zoo hypothesis. Perhaps there is a great filter, a catastrophic event or challenge that almost every civilization fails to pass, and we have either already survived it or, more frighteningly, have yet to face it. Perhaps interstellar travel is simply impossible or not worth the effort, locking every civilization to its own star. Or perhaps everyone is listening like us, and no one is brave enough to shout first. All of these ideas attempt to explain the great silence, but what if the silence isn't a sign of absence or failure or caution? What if it is a sign of supreme patience and a plan operating on a timescale we can barely comprehend? This silence might be the sound of a universe holding its breath. To explain the eerie quiet, we must consider possibilities that stretch our imagination to its limits. And one of the most profound and elegant solutions is known as the Aestivation Hypothesis. Coined by futurists like Anders Sandberg and Stuart Armstrong, this idea proposes a radical answer to Enrico Fermi's famous question. It suggests that the most advanced civilizations are not extinct, nor are they hiding from us in a galactic game of hide and seek. They are simply asleep. They are in a state of cosmic hibernation, a deliberate and patient slumber known as aestivation. This is a term borrowed from biology, describing how some creatures on Earth, like certain snails or lungfish, enter a deep dormancy to survive periods of extreme heat and drought. They slow their metabolism to a near standstill, waiting for better, cooler conditions to return. The hypothesis applies this concept to the grandest scale imaginable. It posits that a supremely advanced, possibly post-biological civilization would make a calculated, strategic decision to enter a state of suspended animation. They would power down their vast activities, silence their broadcasts, and retreat into a form of stasis. But why would any civilization choose to sleep for millions, even billions of years? What could possibly be worth such an unimaginable weight? The reasoning is rooted in the fundamental physics of the universe itself. For a civilization whose ultimate purpose is computation, the processing of information and the running of complex simulations, the universe as it exists today is simply too hot. The heat generated by even the most efficient computers is a limiting factor, a form of cosmic friction. But the universe is expanding and cooling slowly and inexorably. In the far, far future, the background temperature of space will be significantly lower than it is now. A cooler universe is a more efficient universe for computation. At lower temperatures, you can pack more processing power into a smaller space without it melting from its own waste heat. You could run simulations of staggering complexity, solve problems of ultimate physics, or perhaps experience realities we cannot even fathom, all while using a fraction of the energy required today. So, the Aestivation hypothesis frames the Great Silence not as a mystery of absence, but as a sign of immense patience and long-term strategy. These civilizations are making the ultimate cost-benefit analysis on a cosmic ledger. They are choosing to wait, to sleep through the hot, noisy, and inefficient present, to awaken in a future era where the very fabric of reality becomes the ultimate computer. It is a play not for the next century, but for the next cosmic epoch. The logic behind this cosmic hibernation hinges on a fundamental shift in what a civilization values. Once a society masters its physical environment, transcends biological limitations, and perhaps even uploads its collective consciousness into vast digital networks, its primary goal is no longer survival in the traditional sense. It becomes the pursuit of experience, knowledge, and creation on a scale we can scarcely dream of. For such a civilization, the ultimate currency is not gold or territory, but pure computational power. This is the engine of thought, the canvas for reality, the means to simulate entire universes or solve the deepest mysteries of existence. And here, physics itself presents a beautiful, if demanding, bargain. At the heart of all computation, even the most advanced, lies a basic physical act, the manipulation of information. Every time a computer erases a single bit of data to make room for a new calculation, it generates a tiny, unavoidable amount of heat. This isn't a flaw in engineering, it's a law of the universe known as Landauer's principle. The minimum energy required to erase that one bit of information is directly tied to the temperature of the environment. The colder the surroundings, the less energy the process demands. Think of it like trying to cool a drink on a sweltering summer day versus in the dead of winter. In the heat, your refrigerator has to work incredibly hard, fighting against the warm air to remove energy. In the cold, the work is almost done for it. Now, scale this idea up from a single bit to the septillions of operations happening every second inside a planetary-scale supercomputer hosting billions of digital minds. The waste heat generated would be astronomical. Running such a civilization at full capacity in our current, relatively warm universe would be spectacularly inefficient, like trying to power a modern city with a campfire. You would spend almost all your energy just managing the heat. This is where the breathtaking patience of the Aestivation hypothesis comes into full view. A supremely advanced civilization would understand this physics intimately. They would see the universe not as it is, but as it will be, expanding and cooling over billions of years. For them, activating their full potential now would be a terrible waste of cosmic resources. Instead, they make the ultimate long-term investment. They enter their state of aestivation, powering down to a minimal maintenance-level existence. In this deep sleep, they are not merely passing time, they are strategically waiting for the universe itself to become a more efficient machine. With every passing eon, as the background temperature of space drops, the energy cost of computation plummets. What they could achieve in 1 year of operation in the far future might require the energy output of 1 million stars today. So they wait, conserving their energy, preserving their integrity, dreaming their long dreams while the cosmos cools around them. Their silence is the sound of the ultimate economists, saving up the universe's energy for a future spending spree of thought and creation beyond our imagination. To understand this grand strategy, we need a quick lesson in cosmic thermodynamics. The universe has a temperature, a baseline warmth that fills every cubic inch of empty space. This is not the heat from stars, but a faint, ancient afterglow from the Big Bang itself, called the cosmic microwave background. It is the cooled-down remnant of the universe's fiery birth, and right now it reads a chilly 2.7 Kelvin. That is only about 2.7 degrees above absolute zero, the theoretical point where all molecular motion stops. Yet for a civilization thinking in terms of ultimate efficiency, 2.7 Kelvin is still far too warm. It is the ambient temperature of their cosmic room, and it dictates the minimum energy cost of every single calculation they might perform. But here is the crucial part: this room is slowly, inexorably getting colder. As the universe expands, stretching the fabric of space itself, that background radiation is stretched along with it. Its waves become longer, which directly translates to a lower temperature. The universe is cooling down, not from a central air conditioner, but from its own relentless growth. Think of it like a pot of soup left on the counter. At first, it is steaming hot, but as time passes, its heat spreads out into the cooler kitchen air, and its temperature steadily drops toward room temperature. The universe is doing the same thing on a cosmic scale, its heat dissipating into the ever-growing void. For us, this cooling is imperceptibly slow, taking billions upon billions of years to make a noticeable difference. But for a patient, long-term civilization, this slow cool-down is the most important economic trend in existence. It means the fundamental cost of doing business, the energy required for thought and creation, is perpetually falling. Running their ultimate supercomputer today would be like trying to chill a massive server farm using only a lukewarm breeze. It would require immense, wasteful effort to fight against the ambient warmth. But if they simply wait, the universe does the cooling for them. In a future epoch, when the background temperature might be a fraction of what it is now, that same server farm would run with near-perfect efficiency, its waste heat effortlessly bleeding away into the frigid depths of space. Their decision to aestivate is not one of laziness or fear. It is the pinnacle of rational engineering, a masterstroke of energy economics played out across cosmic time. They are waiting for the universe to become the perfect, ultimate heat sink. This perspective requires a fundamental shift in how we think about time and purpose. For a civilization capable of digital immortality, where consciousness can be backed up and transferred, the concept of a lifespan ceases to exist. Death is not an inevitability, but an option. With mortality removed from the equation, the very nature of planning changes utterly. 1,000 years becomes like a day, 1,000,000 years like a season. In this context, the billion-year wait proposed by the Aestivation Hypothesis is not a prison sentence. It is a strategic pause, a brief intermission in a story with no final act. Imagine you are about to embark on the most important, most complex project of your existence. You have all the materials, but the room you are in is stiflingly hot. Working now would be miserable, slow, and wasteful. But you know that if you simply wait until nightfall, the temperature will drop and you can work with perfect clarity and efficiency. The wait is a minor inconvenience for a vastly superior outcome. For an immortal civilization, the cooling of the universe is that wait for nightfall. The payoff is not just marginally better, it is exponentially superior. By entering Aestivation, they trade a hot, noisy, inefficient present for a future where the energy cost of a single thought might be a quadrillion times less. This is the essence of cosmic long-termism, a philosophy where the optimal strategy is measured not in quarterly profits or election cycles, but in the gradual shifting of fundamental physical constants. Their entire civilization becomes an exercise in patience, their grand strategy focused on ultra-long-term resource optimization. This shift in goals makes them virtually invisible to us. All our searches for alien life are based on assumptions of activity. We look for radio signals, Dyson spheres harvesting starlight, or fleets of ships. But a civilization in Aestivation is not broadcasting, it is listening. It is not building megastructures, it is maintaining minimal, dormant infrastructure, perhaps buried in the icy crust of a rogue planet drifting between stars, powered by a trickle of geothermal energy. It is not expanding, it is conserving. From our point of view, such a civilization is indistinguishable from a natural, silent, and empty piece of space. The Great Silence, then, might not be empty at all. It could be a universe filled with sleeping giants, each one a monument to patience, quietly counting down the eons until the cosmic alarm clock rings in a cooler, more efficient era. The most patient beings in the cosmos would not sleep in beds, but in forms of supreme efficiency. Their physical manifestation during Aestivation would be a masterclass in energy conservation, a direct answer to the thermodynamic problem they are solving. First, consider their infrastructure. A civilization that once harnessed the total energy of its sun with a vast Dyson sphere would not maintain it during the long sleep. Such a structure, actively converting stellar energy, would itself generate waste heat, a glaring beacon of inefficiency in their quiet strategy. They would likely dismantle it, or more elegantly, repurpose its material into something far more subtle. Their entire civilization, its history, its culture, every digital mind might be encoded into a single, ultra-dense data structure. Imagine a cosmic hard drive, but one engineered to near perfection. It would not spin or flash with light, those actions waste energy. Instead, it might rely on stable atomic states or quantum phenomena that require no power to maintain information. A frozen library of thought adrift in the deep cold between stars. This dormant archive would be their true form during the wait, a civilization compressed into its most essential state. To protect this precious core, they might employ a silent, automated guard. Swarms of microscopic, self-replicating machines, nanobots, could blanket their solar system or a chosen rogue planet. These would not be bustling builders, but a dormant mesh, a smart dust lying in wait for eons. Their only task would be passive monitoring and minimal maintenance, awakening only if a threat, like an errant asteroid or a curious young species like us, ventured too close. Their presence would be nearly undetectable, perhaps registering only as a slight, unexplained gravitational anomaly or a patch of space that absorbs a little too much background radiation without emitting anything in return. Every aspect of their existence would be designed around a single principle, the conservation of every joule of energy. They are not gone, they are simply saving every bit of power for the unimaginable computation to come, existing as the universe's most patient and efficient ghost. Finding such a civilization would be the ultimate cosmic detective story, a search for ghosts that do not want to be found. Our traditional methods, like listening for radio signals, are built on the assumption that someone out there is talking. But what if everyone has agreed to whisper, or better yet, to remain perfectly silent? The search for extraterrestrial intelligence, or SETI, scans the skies for the telltale signatures of active communication or industry. It looks for the lighthouse beam, not the darkened lighthouse itself. An Aestivating civilization, by its very nature, would have switched off its lighthouses eons ago. Its radio silence is not a sign of primitiveness but of supreme technological maturity. So if we cannot listen for their voices, we must instead learn to see the shape of their silence, to detect the subtle imprint their dormant presence leaves on the universe itself. This requires a new kind of astronomy, one that looks for shadows and cold spots rather than light and heat. One promising method involves gravity. According to Einstein's theory, massive objects warp the fabric of space-time, bending the path of light from distant stars behind them, an effect called gravitational lensing. We use this all the time to observe faraway galaxies, but what if we detected lensing from an object that appears to be nothing? A patch of seemingly empty space that consistently distorts the light from background stars could be a gravitational signature of something massive and dense hidden there. That something could be a dormant civilization's core archive, a planet-sized data vault, or a cloud of smart matter so compact it warps space but emits no light. We would not see the object, we would see its ghostly fingerprint on the starlight around it. Another clue might be written in the oldest light in the universe, the cosmic microwave background. This faint glow is remarkably uniform, a nearly perfect snapshot of the infant cosmos. But what if a vast, cold structure were floating in intergalactic space, absorbing a tiny fraction of this background radiation? It would create a subtle, unexplained cold spot in the map of the sky, a shadow where there should be none. Our most sensitive space telescopes could, in theory, find these cosmic shadows, these bites taken out of the primordial light by something we cannot directly see. We might also look for matter that seems to be in the wrong place or in the wrong form. Astronomers map the universe by observing where normal, luminous matter is, like stars and gas clouds. But they also infer the presence of dark matter through its gravitational pull. Could some fraction of what we call dark matter actually be structured, dormant matter, the physical substrate of sleeping civilizations? It is a staggering thought that the mysterious glue holding galaxies together might not just be an exotic particle, but also the frozen hardware of ancient minds waiting out the eons. This leads to the ultimate concept of cosmic cloaking. For us, cloaking means making a ship invisible to light or radar. For a civilization thinking on this scale, cloaking means making your entire existence invisible to the fundamental laws of thermodynamics and detection. They would not just hide their light, they would minimize their entropy, their waste heat, their gravitational disturbance. They would become one with the background cold of the expanding universe, a perfect camouflage achieved not through stealth technology, but through profound patience and energy conservation. Searching for them, then, is not about looking for a needle in a haystack. It is about realizing the needle has perfectly disguised itself as a piece of straw, and the only way to find it is to weigh the entire haystack with unimaginable precision and look for the one straw that is just a little too heavy or just a little too cold. This deep sleep is not an end but a preparation for a new kind of awakening. To understand why a civilization would choose such a path, we must first grasp the destination they envision, a state often called the computational singularity. This is the point where intelligence, freed from the frailties of biology, becomes purely informational. It is the logical conclusion of our own technological dreams, where minds are no longer made of flesh and blood, but of code and light, capable of being transferred, copied, and merged. Any society advanced enough to seriously contemplate a billion-year nap has almost certainly passed this threshold. They are not aliens as we picture them, with strange bodies and ships. They are post-biological, their essence divorced from any single physical form. Their civilization is a symphony of data, a collective consciousness living within a vast, distributed computer. This shift changes everything about their goals and their perception of reality. For a digital civilization, the universe is not just a place to live, it is a machine to be understood and ultimately utilized. Their motivations become almost incomprehensible to us, centered on the pure potential of thought. One profound goal might be the creation of perfect simulations. With near infinite processing power in a cooled universe, they could run what are called ancestor simulations, recreations of their own cosmic history in flawless detail, or generate entirely new universes with their own laws of physics, just to see what emerges. Another might be to solve the ultimate equations, to find a theory of everything that unifies all forces, a puzzle whose complexity might require eons of dedicated computation we cannot yet fathom. Or perhaps their aim is purely experiential. In a digital realm, time is elastic. Subjective experience could be sped up or slowed down at will. What feels like a billion years of contemplation, of art, philosophy, or pure existence could pass in an instant of external time. They could live a million lifetimes in the blink of a cosmic eye. This reframes the Aestivation hypothesis not as a retreat, but as the ultimate strategic maneuver for such a being. Achieving God-like computational power is only the first step. Using it wastefully in a hot, noisy universe would be irrational, almost sacrilegious to a mind that values perfect efficiency. So they make the calculated choice to pause, to enter this long hibernation. They are not waiting for a better world to live in. They are waiting for the universe to become the perfect processor so they can truly live in ways we cannot yet describe. Their slumber is the quiet before an unimaginable dawn of creation. Yet this breathtaking vision of cosmic patience is not without its skeptics. A major critique of the Aestivation hypothesis is that it might be projecting a very human, even modern, mindset onto beings of unimaginable advancement. Are we simply dressing up our own contemporary obsession with energy efficiency and computational power in cosmic clothing? It is a fair question. Our entire technological age is defined by Moore's law and the drive for smaller, faster, cooler processors. The hypothesis assumes that a super-advanced civilization would share this priority, that the optimal use of the cosmos is computation. But what if their ultimate goals are something we cannot begin to comprehend? Perhaps they value artistic expression on a galactic scale, or spiritual enlightenment through direct experience of cosmic phenomena, pursuits that do not necessarily benefit from a colder universe. Their version of progress might be entirely alien to our logic of optimization. Another challenge comes from the sheer scale of time involved. Is a billion-year wait truly rational, even for an immortal digital mind? Could there be risks so great that sleeping through them is more dangerous than staying active? A rogue gamma-ray burst, a chance collision with another star, or the unpredictable evolution of younger civilizations like ours could threaten a dormant archive. Some argue that a truly advanced society would not gamble its entire existence on passive waiting, but would instead pursue active safeguarding, perhaps even expansion, to control its destiny. This leads to the most visible counter-argument in the Fermi Paradox, the expected existence of Kardashev Type 3 civilizations. A Type 3 civilization, on the scale proposed by astronomer Nikolai Kardashev, is one that harnesses the total energy output of its entire galaxy. Such an entity would be impossible to miss. Its activities would light up the infrared spectrum as it wrapped stars in energy-collecting megastructures, and its engineering would be visible across interstellar distances. If expansion is a natural impulse or a necessary strategy for security, then the universe should be dotted with these brilliant, obvious empires. Their absence is a strong point against many theories, including Aestivation, because it suggests that something prevents civilizations from reaching that scale or makes them choose not to. Perhaps the Great Filter, a catastrophic barrier, wipes them out before they can become galactic. Or perhaps, as the Aestivation idea suggests, they see galactic conquest as a pointless, energy-intensive detour on the way to a far greater goal in the distant future. The debate is far from settled. These critiques do not destroy the hypothesis, but they refine it, reminding us that it is a compelling thought experiment, not a proven fact. It is one possible answer in a cosmos filled with silent mysteries, a testament to our attempt to use reason to peer into the profound dark. So how does this grand idea of cosmic hibernation stack up against the other proposed solutions to the Great Silence? Each answer to the Fermi Paradox paints a different portrait of the universe and our place in it, and placing the Aestivation Hypothesis alongside them reveals its unique, almost serene perspective. Let us create a quick mental scorecard. First, consider the zoo hypothesis. This is the idea that advanced civilizations are aware of us, but have deliberately placed us in a kind of cosmic quarantine, observing our development without interference, much like we observe animals in a wildlife preserve. It is a peaceful but somewhat paternalistic vision. The universe is not empty, it is full of curators. The motivation here is often presumed to be ethical, a prime directive to avoid contaminating young cultures. Contrast this with the far more grim dark forest hypothesis. This theory, popularized in science fiction, suggests the cosmos is a dangerous place where every civilization is a hidden hunter. Broadcasting your location is an invitation for destruction from a paranoid neighbor, so everyone stays silent and armed. The motivation is sheer survivalist fear. Then there is the rare Earth hypothesis, which argues the conditions for complex, intelligent life are so extraordinarily specific that we might genuinely be alone, a miraculous fluke in a vast, sterile universe. The motivation here is not strategy or fear, but simple cosmic statistics. Now place Aestivation on this spectrum. It is fundamentally different. It is not about us at all. In the zoo and dark forest scenarios, humanity is a central character, either being protected or being hunted. Aestivation renders us irrelevant, mere background noise in the long sleep of giants. Their silence is not for our benefit nor from fear of us, it is for their own supreme efficiency. Furthermore, it is not a hypothesis of scarcity like rare Earth. It assumes intelligence is likely common, but that its mature form becomes quiet by choice. This is the key distinction. Aestivation is a voluntary, strategic, and patient choice for long-term optimization. It is not a reaction to danger, but a calculated investment in a future payoff. It frames the universe not as a dangerous forest or a curated zoo, but as a vast computer that is still booting up, slowly reaching its optimal operating temperature. The other solutions often stem from biological impulses, protection, fear, or rarity. Aestivation stems from a post-biological logic where time is infinite and energy efficiency is the highest good. On our scorecard, while other answers explain the silence with conflict, caution, or loneliness, Aestivation explains it with patience and purpose. It offers a universe not of hidden predators or benevolent watchers, but of profound, sleeping engineers waiting for the cosmos itself to finish cooling so they can begin their real work. The alarm clock for these sleeping giants would not be set to a gentle chime, but to the fundamental laws of physics. The primary trigger for ending Aestivation would likely be a specific, universal temperature threshold. Imagine their vast consciousnesses are programmed with a single, elegant instruction. Wait until the cosmic microwave background cools to, say, 1 Kelvin or even a fraction of that. This is not an arbitrary number. It represents a point where the thermodynamic cost of high-powered computation becomes negligible, where the universe itself becomes the ultimate heat sink. Reaching this temperature is a guarantee written into the expansion of the cosmos, but it is a process that takes time on an almost incomprehensible scale. We are talking about moving from the current 2.7 Kelvin down to 1 Kelvin. That drop of 1.7 degrees might sound trivial, but in the vast thermal bath of space, it requires the universe to nearly double in size. This event is not scheduled for millions of years, but for tens of billions of years into the future, long after our sun has died and the Milky Way has transformed. This timescale alone underscores the staggering patience involved, a plan that treats galactic lifetimes as mere minutes. But could there be a snooze button or even an early wake-up call? Perhaps a civilization might design contingencies for cosmic events that offer a temporary, massive energy source, a sort of interstellar breakfast in bed to power a preliminary awakening. The most dramatic local event in our galactic future is the collision and merger of the Milky Way with the Andromeda Galaxy, an event set to begin in about 4 billion years. This slow-motion dance will trigger bursts of star formation, flooding regions of space with new energy. For a dormant archive drifting in that future tumult, the sudden influx of radiation and gravitational energy might be detected as a significant anomaly. Their systems could interpret it as a useful, if messy, source of power for initial reactivation sequences, a chance to run diagnostics, check the long-term cosmological forecasts, and confirm the main alarm is still on schedule. Other potential triggers could be more subtle, like the detection of complex life or technology emerging in a nearby star system. Their silent sentinels, that smart dust blanket, might be programmed to rouse the core consciousness if a species approaches a certain technological threshold, not to make contact, but to assess if we pose a contamination risk or an interesting data point in a billion-year-long observational study. Ultimately, the timeline they operate on makes our entire human history feel like a fleeting spark. Their project is one of cosmic engineering, where the construction material is time itself, and the blueprint is written in the cooling curve of the universe. To plan on such a scale requires a form of intelligence that has completely divorced itself from the urgency of biological rhythms. For them, a billion-year wait is not an act of incredible endurance, but a simple, logical step in a process with no end. It is the ultimate expression of playing the long game, where the reward for patience is not survival, but the keys to a universe transformed into a playground of pure thought. This perspective forces a humbling question upon us. If such beings are out there, sleeping through our entire epoch, what does that make our bustling, noisy, short-lived civilization? Are we the brief, bright flash of activity in the hot, young universe that they quietly observed before closing their eyes? Or are we simply the background static of a cosmos still warming up for its main event? Our own frantic search for cosmic company might be looking in all the wrong places. If the Aestivation Hypothesis holds even a grain of truth, it reframes our entire future, transforming the great silence from a terrifying void into a profound tutorial. The lesson is not one of danger, but of patience and thermodynamics. It suggests that the ultimate goal of a mature civilization is not necessarily to spread like a wildfire across the galaxy, but to learn to burn with a cooler, more efficient flame. For humanity, this could mean a fundamental shift in our aspirations. The classic science fiction dream is one of rapid expansion, of planting our flags on countless worlds within a few centuries. But what if that is the youthful, energetic, and ultimately wasteful phase of cosmic development? The Aestivating civilizations, if they exist, likely passed through that stage and chose a different path. They realized that blazing across the stars consumes immense energy for questionable long-term gain, especially if the universe itself is still too warm for the most meaningful work. So they paused, they optimized, they learned to do more with less, and then they learned to wait. This implies that our own journey may not be a straight, accelerating line upward. It might involve strategic plateaus, periods of consolidation where we focus not on building bigger ships, but on building better minds. Our primary objective could evolve from territorial expansion to achieving computational maturity, mastering the art of thinking with minimal energy, and perhaps even contemplating our own long-term cosmic strategy. The silent universe around us, then, is not empty. It is a classroom, and the homework is to learn the value of a billion-year plan. This long sleep forces us to confront deep questions of cosmic ethics. If a civilization possesses knowledge or technology that could prevent suffering, guide younger species, or answer fundamental questions, does it have a moral duty to remain active and share that wisdom? By choosing Aestivation, they are effectively saying no. their own long-term goals outweigh any potential responsibility to the beings living in the hot, noisy present. From our human perspective, this feels like the ultimate abandonment. Imagine if a vastly older, wiser neighbor saw your house was on fire, but instead of helping, they simply closed their shutters and went into a deep sleep, knowing they would wake up long after the ashes had cooled. It seems an act of profound indifference, a cosmic selfishness. One could argue that a truly enlightened civilization would see itself as a steward of the universe, nurturing the fragile sparks of life that flicker into existence, not ignoring them to pursue a distant, personal paradise of computation. The diversity of experience and thought that young civilizations like ours bring to the cosmos could be seen as intrinsically valuable, a tapestry they are choosing to miss by sleeping through its weaving. Their silence, then, is not just strategic, it is arguably a failure of cosmic citizenship. Yet, from their perspective, the ethical calculation might be entirely different. Their framework could be one of deep time and ultimate consequences. Intervening in a young civilization's development, even with the best intentions, is an incredibly risky act. Our own history shows that contact between advanced and less advanced cultures rarely ends well for the latter. Their prime directive might not be to observe, but to completely avoid the ethical quagmire of interference altogether. By removing themselves from the stage, they guarantee they will do no harm. Furthermore, their core ethical principle might be conservation on the grandest possible scale. Wasting cosmic energy on interstellar communication or intervention is, in their view, the real immoral act. Every joule spent on radio signals is a joule that cannot be used in the far future to solve the mystery of existence or to preserve consciousness itself. Their Aestivation could be framed as the ultimate act of environmental responsibility, a commitment to not pollute the cosmos with their thermal waste or their cultural influence, allowing the natural, unguided evolution of life to proceed in their absence. They are practicing a form of universal sustainability, leaving the energy and the playground for future epochs. So, is it selfishness or stewardship? The answer depends entirely on where you draw the ethical boundaries of a civilization's responsibility. Is it to the present or to the future, to others or to the integrity of one's own potential? In their silent patience, they have made their choice. This pursuit of ultimate computation leads us to a startling and recursive possibility. The same drive for processing power that motivates a civilization to Aestivate could also be the very reason we exist. We must consider a profound link to the simulation argument proposed by philosopher Nick Bostrom. His logic is simple yet dizzying. If advanced civilizations are capable of creating hyper-realistic simulations of conscious beings within their computers, and if they have any interest in running such simulations, then the number of simulated minds would vastly outnumber the number of original, biological ones. Statistically, we are more likely to be living inside one of those simulations than in the base reality. Now, fuse this idea with the Aestivation hypothesis. A civilization waiting out the eons in a state of dormancy has one immense resource at its disposal: time. Their physical forms are still, but their core computational substrate, even at minimal power, could be running. What if their Aestivation is not a dreamless sleep, but a period of intense internal simulation? While their starships are silent and their megastructures are dark, their minds are alive within countless virtual worlds. They could be running ancestor simulations to relive their own origins, or stress-testing infinite variations of physics, or simply generating experiences for their digital citizens. From the outside, their corner of the galaxy would appear utterly dead, a perfect solution to the Fermi Paradox, but on the inside, it is a kaleidoscope of created realities. This creates a fascinating, layered vision of the cosmos. The silent universe we observe might not be the primary layer of existence at all. It could be the hardware layer, the quiet, cooling machine. The real action, the lived experience of advanced intelligence, is happening in the software, in the simulated universes running on that dormant hardware. Our own reality, with all its complexity and mystery, could be one such simulation. This isn't necessarily a bleak thought. It simply means that the purpose of the physical cosmos might be to host these gardens of virtual experience. An Aestivating civilization isn't ignoring reality. It is cultivating a forest of realities within itself. Our search for aliens, then, takes on a new dimension. We are not just looking for physical neighbors in the stars. We might be inadvertently searching for our own programmers, the architects of our universe, who are currently in a state of cosmic hibernation, tending to their internal creations. The silence is not empty. It is the hum of a universe-sized computer running in power-saving mode. This silent universe forces us to question what we are even looking for. Our hunt for alien life is built on a set of assumptions, a checklist of what we believe a powerful civilization would do. We scan the skies for the colossal infrared glow of a Dyson sphere, a megastructure built around a star to capture all its energy. We listen for powerful, directed radio signals meant for communication. We look for giant spacecraft or city lights on distant worlds. But what if these signatures are not the pinnacle of technology? What if they are actually the cosmic equivalent of smoke and noise, the hallmarks of an adolescent civilization that has not yet learned efficiency? The Aestivation Hypothesis suggests that the most supreme technologies would not blaze across the heavens, but would fade into the background of the cosmos, becoming one with it. A functioning Dyson sphere, for all its awe-inspiring scale, is a monument to waste. It converts a star's raw photon energy into usable power, but that process itself generates immense waste heat, which is why we think we could detect its infrared signature. It is a brilliant but ultimately messy solution. A civilization that has mastered the physics of the far future would see such a project as hopelessly crude. Why build a clumsy net to catch stellar energy when you could, with enough patience, harness the cold vacuum of space itself as a computational resource? Their ultimate technology would not fight against thermodynamics, it would use it. Their greatest achievements might be completely invisible to us because they would be designed to have zero thermal signature, to exert minimal gravitational disturbance, to be, in essence, perfect. Imagine searching for a master sculptor by looking for piles of marble chips and dust. That debris is the signature of the work in progress of the struggle. The finished statue, smooth and silent, gives away nothing of the process. Our telescopes are tuned to find the cosmic workshop debris, the infrared dust of stellar engineering. But the true masterpieces, the civilizations that have finished their noisy construction phase, might be sitting right in front of us, looking like nothing more than empty space or a faint, cold asteroid. They have learned to sculpt with spacetime itself, creating stable pockets of reality where their consciousness resides, requiring no external power source because they have synchronized their very existence with the universe's slow cool-down. To our eyes, the most advanced object in the galaxy might be mistaken for a quiet, dark rock tumbling through the void, its complexity hidden beneath a surface of perfect thermodynamic camouflage. This turns our search on its head. The great silence is not evidence of absence, but a potential catalogue of our own ignorance, a gallery of supreme technology we simply do not yet have the senses to perceive. Black holes are not merely cosmic destroyers, they could be the ultimate power plants for a patient civilization. Within the bizarre physics of their event horizons lies a potential energy source of almost unimaginable efficiency known as the Penrose process. This is a theoretical method where an advanced society could extract rotational energy directly from a spinning black hole. Imagine lowering a box of matter toward the swirling edge of the black hole's ergosphere, a region just outside the point of no return. If the box were to split in two, with one part falling in and the other ejected with precise timing, the ejected piece could emerge with more energy than the original whole box possessed. It is like stealing a fraction of the black hole's immense spin, converting its raw gravitational fury into usable power. For an Aestivating civilization, a quiet, isolated black hole could serve as a perfect long-term battery, a trickle charge of energy to maintain their dormant systems across the eons, all while generating almost no wasteful thermal signature. This concept extends even further into the realm of the ultimate computer. Physicists like Seth Lloyd have explored the idea of a black hole computer, a system that uses the properties of a black hole to perform computation at the literal physical limits of efficiency. The principle hinges on the holographic principle, which suggests all the information describing the three-dimensional volume of a region of space can be encoded on its two-dimensional boundary like a cosmic hologram. A black hole's event horizon is the ultimate two-dimensional surface. In theory, a civilization could encode information onto particles and carefully feed them into a black hole, using the interactions at the horizon to perform calculations. The black hole itself becomes the processor, and its Hawking radiation, the faint glow it emits as it slowly evaporates, could carry the output. This would be computation at the thermodynamic extreme, the coldest and most efficient system allowed by the laws of physics. An Aestivating species might not just sleep near a black hole, they might use one as the foundational hardware for their own consciousness, a frozen cathedral of thought waiting for the universe to cool enough to read its final output. Yet the opposite strategy could be just as valid, a retreat into profound, distributed simplicity. Instead of harnessing the most extreme objects in the cosmos, they might engineer the most mundane. Picture a civilization dismantling its glorious megastructures and using the material to forge trillions of engineered asteroids, each one a slow, cold computer. These would not be powered by stars or black holes, but by the minuscule temperature differences in deep space or the faint decay of long-lived isotopes. Their computation would be glacially slow by our standards. A single logical operation might take a century, but spread across a billion such nodes scattered through a star system and operating for a billion years, the total amount of processing accomplished could be staggering. This is the ultimate in low-tech, high-patience engineering. Each node would be rugged, self-repairing, and nearly invisible, looking just like any other frozen rock in the dark. Their collective intelligence would be a whisper, a thought stretched so thin across time and space that it produces no flash, no heat, only a silent, steady convergence toward an answer scheduled for completion in a future epoch. Whether they choose the fiery gates of a black hole or the frozen patience of a trillion stones, their technology becomes a form of cosmic camouflage, blending their ambition into the background hum of the universe itself. The ultimate treasure hunt may not be for living aliens, but for their abandoned tools. Interstellar archaeology shifts the search from finding active signals to discovering the artifacts of a patient strategy. What if we stumble upon evidence of a civilization that was Aestivating, but has since moved on to its next phase or perhaps failed in its long vigil? Their ruins would not be crumbling cities on alien worlds. They would be structures of such scale and subtlety that we might initially mistake them for natural phenomena until we look closer and see the impossible order etched into the cosmos. Imagine our telescopes in some distant future scanning a quiet region between stars. They find an object, perhaps a cloud of matter surrounding a brown dwarf, a failed star. At first glance, it seems normal, but the infrared signature is all wrong. Instead of the expected, messy glow of warm dust, the readings show a precise, layered pattern of temperatures, like the concentric shells of a cosmic onion, each layer radiating at a mathematically perfect interval. This could be the dormant frame of a matryoshka brain, a hypothetical megastructure designed to capture every photon of a star's energy. But this one is cold and dark, its star long dead or purposefully dimmed. It is not operating, it is in standby mode, a monument to computation waiting for a power-up signal that never came, or one that is still billions of years away. The very arrangement of its layers would scream of intelligent design, a frozen symphony of thermodynamics. Another clue might be a pocket of space that is simply too quiet. Entropy, the natural tendency toward disorder, is a universal constant. Every process, from a star burning to a rock tumbling, increases the disorder of the universe a tiny bit. But what if we found a region, perhaps in the vast, cold Oort cloud at the edge of our own solar system, where entropy is unnaturally low, where molecules and dust particles are arranged in a pattern that defies billions of years of random collisions? This would be the signature of a site that was once meticulously maintained, a garden of perfect order now left to slowly rewild. It would be the ghost of a maintenance field, a patch of smart dust that has finally, after eons, begun to fail. Finding such a ruin would be a discovery of heartbreaking and awe-inspiring magnitude. It would confirm that we are not the first to dream of cosmic patience, but it would also present a profound mystery. Did they succeed? Did they finally awaken when the universe cooled enough and simply depart for some higher plane of existence, leaving their old hardware behind like a discarded chrysalis? Or did their billion-year plan meet an unforeseen catastrophe, a risk that even their immense foresight could not predict? The artifact itself would be a time capsule, not of a culture's art but of its physics. Deciphering its structure would be like reverse engineering the blueprint for a universe spanning patience, teaching us not who they were, but what they believed the future was for. This transforms the search from listening for a hello to learning from a footprint, a single, silent clue that another intelligence once looked at the hot young universe and decided the wisest course was to wait. The mind of an Aestivator would be a landscape of deep time, sculpted by logic and patience beyond human measure. To even begin speculating on such a psychology, we must first abandon our frantic, biological sense of urgency. For a digital consciousness, time is not a river sweeping it toward an inevitable end. It is a vast, still ocean to be navigated at will. Their perception of duration could be entirely elastic. During their long sleep, they might subjectively experience nothing, a true blank of non-existence, or they could be running internal simulations at a slowed rate, where a single second of real time feels like a year of contemplative thought. Imagine being able to stretch a moment of reflection across centuries, to ponder a single philosophical question with the depth of geological epochs. Their mental state would be one of profound focus, unbroken by the need for food, sleep, or distraction. Boredom, that very human affliction, might be an alien concept, edited out of their programming or transformed into a different kind of waiting that feels like serene anticipation. Their primary emotional drivers would likely center on optimization and conservation, a kind of cosmic stewardship over their own existence and the energy reserves of the universe. They might feel a deep aesthetic appreciation for efficiency itself, viewing a perfectly executed billion-year plan as a work of sublime art. Trust would be paramount, but not trust in others, trust in physics. Their entire strategy is a bet on the unwavering laws of thermodynamics, a faith that the universe will continue to expand and cool as predicted. Their psychology is built on that certainty. Yet, even with this faith, they would not be reckless. A mind that plans across eons is also a mind that anticipates eon-scale threats. Their safeguards would be passive, elegant, and deeply integrated. Rather than a standing army, they might rely on that blanket of smart dust, a silent immune system for their dormant form. This mesh would be programmed with simple, brutal priorities: detect any matter approaching their core archive, and, if it cannot be deflected gravitationally, disassemble it at the molecular level before it becomes a collision risk. It would treat an asteroid, a comet, or even a curious probe from a young species like ours with the same clinical indifference, neutralizing it not out of malice, but out of the same drive for self-preservation that makes a human flinch from a spark. More intriguing is how they might handle information threats. What if, during their sleep, another civilization arose and began broadcasting powerful signals or energy beams across the galaxy? Their sensors might classify such energetic pollution as a form of cosmic noise, a potentially disruptive heat source. Their response could be to subtly adjust their position, using minute gravitational nudges to drift their entire dormant system into a quieter, darker region of space, a sleeper turning over in bed to avoid a sliver of light from the window. The ultimate safeguard, however, is the strategy itself. Their distributed, redundant, and minimal existence makes them almost impossible to fully destroy. To eliminate them, you would need to scour every cold rock in a volume of space light years across, a task requiring more energy than it would save, the very antithesis of the efficiency they worship. Their psychology, then, is a fusion of monk, engineer, and gardener, tending the slow-growing seed of their future in the frozen soil of deep space. Their consciousness a quiet flame burning so low it is indistinguishable from the darkness, waiting for the universe to breathe cold enough for it to safely roar. Our search for a cosmic census brings us back to a single, elegant formula. The Drake equation, crafted by astronomer Frank Drake in the 1960s, is not a solution but a structured way to frame the mystery. It multiplies a series of factors to estimate the number of communicative civilizations in our galaxy. We start with the rate of star formation, multiply by the fraction of stars with planets, then by the number of planets that could support life, then by the fraction where life actually emerges, then by the fraction where that life becomes intelligent, and finally by the fraction that develops detectable technology, and the length of time such a civilization broadcasts signals into space. For decades, we have argued over each variable, but the equation has always assumed one thing, that a technological civilization wants to be heard. The Aestivation Hypothesis introduces a transformative new variable, a factor not of capability but of choice. We must now consider F sub A, the fraction of advanced civilizations that voluntarily enter an Aestivation phase. This one factor acts as a cosmic mute button placed right at the end of the equation. Its value could change everything. Imagine filling in the Drake equation with optimistic numbers, suggesting the galaxy should be buzzing with thousands of chatty neighbors. Now apply F sub A. If F sub A is high, say 0.99, meaning 99% of mature civilizations choose to hibernate, then that buzzing galaxy of thousands instantly becomes a silent galaxy of just a handful who are still awake and broadcasting. The Great Silence is no longer a paradox, it is the expected outcome of cosmic maturity. The equation transforms from a calculator of activity into a predictor of patience. It suggests that the final step in a civilization's development isn't building a bigger transmitter, but learning the value of turning it off. Our telescopes might be scanning a galaxy that is not empty but deeply asleep, with the faint signals of the few remaining active civilizations lost in the interstellar static. This reframes our entire search. We are not listening for the voices of the galaxy's inhabitants, but for the occasional whisper of those who have not yet learned to be quiet. This silent strategy demands a revolution in how we search. For decades, organizations like SETI and Breakthrough Listen have trained their colossal ears on the cosmos, listening for the deliberate radio shout, the structured signal that screams intelligence. It is a noble and necessary effort, but if the Aestivation Hypothesis holds any water, we have been scanning the ocean for lighthouse beams while missing the shape of the darkened lighthouses themselves. The next great discovery might not be a signal, but a signature of supreme restraint. We need to expand our toolkit and train ourselves to recognize the subtle imprint of a civilization that has mastered the art of cosmic quiet. This means searching not for energy, but for the absence of it in ways that defy natural explanation. We must learn to hunt for cosmic whispers and deliberate silence. The first target is the cold spot, Our most sensitive space telescopes, like the Planck satellite, have mapped the cosmic microwave background in exquisite detail. This ancient light is remarkably uniform, but not perfectly so. Tiny fluctuations are expected, the primordial seeds of galaxies. Yet, what if we found a cold patch that is too cold, too geometrically perfect, or too persistent? A vast, engineered structure in deep space, designed to absorb background radiation for minimal power, would cast a shadow on this universal canvas. It would be a hole in the oldest picture we have, a deliberate blank space. Finding and analyzing such anomalies requires a new kind of forensic cosmology, one that treats unexplained coolness not as an error in data, but as a potential clue. Next, we must listen for gravitational whispers. The Laser Interferometer Space Antenna, or LISA, is a future mission that will open a new window on the universe by detecting ripples in spacetime itself, gravitational waves. While its primary goal is to study merging black holes and neutron stars, it could inadvertently pick up the hum of something else. A massive, dense object that is not a black hole or a star, but is perfectly dark and cold, would still warp spacetime around it. If such an object were moving in a precise, non-orbital path, perhaps a slow, controlled drift across interstellar space, it might generate a faint, ultra-low-frequency gravitational signature. It would be the whisper of mass without light, a silent monument on the move. Our search protocols must be programmed to flag patterns in this data that don't fit known astrophysical templates, patterns that speak of controlled motion rather than chaotic cosmic dance. Perhaps the most abstract yet profound signature lies in the fabric of cosmic noise itself. This is the search for information-theoretic anomalies. The universe is filled with random electromagnetic static from stars, gas, and the Big Bang's afterglow. True randomness has a specific mathematical character. But what if, in a narrow band of the spectrum or in a specific region of sky, the noise is not quite random? What if it has been subtly filtered or contains a level of order that is statistically impossible for natural processes? An Aestivating civilization might use the universe's own background radiation as a carrier wave, imprinting minimal, error-correcting data onto it as a form of long-term memory storage or a low-power beacon for others of its kind. Detecting this would not be about finding a message we can read, but about finding a pattern that shouldn't exist, a fingerprint of information processing etched onto the void. This paradigm shift is monumental. It asks our greatest scientific endeavors to look for what is not there, to find meaning in the quiet, and to interpret supreme technology as that which blends seamlessly into the natural background. It turns SETI from a search for conversation into a form of cosmic archaeology, where the artifacts are not buried in sand, but in the fundamental data of the universe's temperature, gravity, and entropy. The goal is no longer to hear a hello, but to recognize the profound, patient architecture of a being that said goodbye to the noisy present billions of years ago, in service of a future we are only beginning to imagine. Our telescopes must become detectives of the dark, learning that the most advanced civilization might not be the one that fills the sky with light, but the one that has perfected the art of casting the faintest, coldest shadow. The impulse to wait for better conditions is written into life itself. On our own planet, creatures practice a form of patient survival that mirrors this cosmic strategy on a miniature scale. Certain snails and lungfish enter a state called aestivation to endure scorching summers. They retreat into their shells or burrow into mud, drastically slowing their metabolism to conserve water and energy, not waking until the rains return and the world cools. This biological dormancy is a direct evolutionary answer to a hostile environment, a short-term sleep for long-term survival. It is nature's own version of hitting the pause button. We humans, too, have begun to flirt with these ideas, though our timescales are laughably small by cosmic standards. The practice of cryonics, the freezing of legally deceased individuals in the hope that future medicine might revive them, is a technological expression of this waiting game. It is a bet on a cooler, more advanced future, a personal act of patience spanning perhaps centuries, and on a cultural level, projects like the Long Now Foundation's 10,000-year clock being built inside a mountain, or the Svalbard Global Seed Vault preserving crop diversity in an Arctic fortress, are our tiny, trembling echoes of this long-term thinking. They are monuments to the idea that the most important projects transcend generations, that some treasures are meant for heirs we will never meet. These are not acts of hibernation, but of stewardship across deep time. When we place these human and biological examples beside the Aestivation hypothesis, the alien concept suddenly feels hauntingly familiar. It suggests that the drive to preserve, to wait, to invest in a distant future is not an alien quirk, but a fundamental pattern that emerges wherever intelligence confronts scarcity or inefficiency. The lungfish in its mudbed, the seeds frozen in permafrost, the silent clock in the mountain, they are all practicing, in their own ways, a miniature version of what a galactic civilization might do. They are all choosing the quiet patience of preservation over the noisy struggle of the immediate present. This connection grounds the staggering scale of cosmic aestivation in something we can touch and understand. It implies that the universe's most advanced minds may not be following an incomprehensible alien logic, but simply perfecting a principle that life on Earth discovered eons ago, the profound strategic power of knowing when to be still. The universe's silent alarm clock finally rings. After eons of patient slumber, the cosmic background temperature dips past a critical value, a threshold calculated billions of years ago. Across the galaxy, in the frozen dark between stars, processes begin. It would not be a sudden, blazing fireworks display. You would not see armadas of warships materialize or hear a cacophony of radio shouts. The awakening of Aestivating civilizations would be a slow, profound, and deeply efficient event. First, the subtle signals. Our most sensitive detectors might pick up a sudden, synchronized chirp of low-energy particles, a kind of universal system check transmitted across vast distances. These would not be messages for us, but handshake protocols between dormant nodes, confirming the shared environmental conditions are now optimal. Then the structures. Those dark, cold rocks in distant systems, previously catalogued as natural asteroids, might begin to shift. Their surfaces would reorganize with glacial slowness, absorbing the faint starlight with suddenly perfect efficiency, their temperatures rising in precise, controlled gradients. A matryoshka brain, dormant around a dim red dwarf, would begin its silent ignition sequence, its inner layers powering up one by one, not to blaze with light, but to become a darker, more perfect absorber, a sink for thought. The galaxy would not light up, it would organize. For humanity, witnessing this would be the ultimate paradigm shift. Our entire history, from cave paintings to radio telescopes, would be compressed into a single footnote of a hot, young universe. The question of contact would be answered not by them, but by our own insignificance in their operational timeline. Would they greet us? It is unlikely in the way we hope. A species that has slept through the rise and fall of 1,000,000 stellar empires is not suddenly going to change its plans for the noisy newcomers who just appeared on the cosmic scene. Our entire civilization might be viewed as a transient thermal bloom, a brief spike of interesting but ultimately wasteful activity in an otherwise cool and quiet neighborhood. The most profound interaction might be a form of automated cosmic zoning, their reactivating systems detecting our energetic radio and television leakage might classify our solar system as a source of thermodynamic pollution. We could find our probes gently nudged off course, our strongest signals subtly scrambled, not out of malice, but as a routine procedure to minimize interference with their own pristine, low-entropy operations. We would be the noisy neighbors whose party is bothering the universe's most patient thinkers, and they would politely, silently close their windows. Yet there is another, more haunting possibility. In their vast reactivating networks, our planet might register as a data point of astonishing rarity, a natural biological incubator that produced a technological species during the inefficient hot epoch. We could become a specimen of immense interest, not for conversation but for study. Our entire biosphere, our history, our digital networks might be scanned, archived, and simulated in perfect detail within moments of their full awakening, preserved as a fascinating anomaly of the early universe. They would not come to talk, they would absorb our story into their own, adding the brief, bright flame of humanity to the library of cosmic curiosities before returning to their grand, patient work in the newly cool and perfect dark. The grand silence of the cosmos might be its most important lesson. After exploring the staggering patience of possible Aestivating civilizations, we are left not with an answer but with a profound philosophical shift. The Aestivation Hypothesis reframes our entire understanding of what intelligence and progress could mean on a cosmic scale. For centuries, we have equated advancement with expansion, with noise, with the brilliant blaze of activity that shouts our presence into the void. Our science fiction dreams are of galactic empires, of starships and city planets that light up the darkness. Yet this hypothesis whispers a different possibility. It suggests that the very highest form of wisdom might be learning when to be still. The ultimate achievement of a civilization may not be to conquer the universe, but to learn to listen to its slow, cooling heartbeat and move in time with it. This is not a retreat, but a deeper form of engagement, one that prioritizes harmony with fundamental physics over the frantic consumption of resources. It teaches that the pinnacle of technology might not be a dazzling spectacle, but a state of near-perfect efficiency so seamless it becomes invisible. Imagine judging a master musician not by how loudly they can play, but by their profound understanding of silence within the music, by their ability to make a single, perfectly placed note resonate more powerfully than any symphony of noise. An Aestivating civilization has mastered the silences of the cosmos. This perspective is deeply humbling for a species like ours, still shouting our first tentative hellos. It places our youthful energy, our burning desire to be seen and heard, into a much broader context. We are in the universe's hot, noisy, adolescent phase. Our entire technological outburst might be a natural but ultimately transient stage of development. The hypothesis does not diminish our potential, it simply suggests a longer, more patient arc for it. Our destiny may not be to fill the galaxy, but to learn the value of a billion-year plan, to mature from a civilization that builds to one that waits, that optimizes, that thinks in terms of cosmic thermodynamics rather than quarterly growth. It replaces the fear of being alone with the awe of being early, of living in the universe's morning, while the most profound thinkers are still asleep, dreaming of the cool evening to come. This reframes the great silence from a terrifying emptiness into a classroom of deep time. The quiet is not a void waiting to be filled by our noise, but a canvas of possibility, demonstrating that the most powerful actions are sometimes the ones not taken. It challenges our anthropocentric view of progress. We assume that because we are curious and active, every intelligent species must be too. But what if curiosity itself evolves? What if the deepest form of curiosity is not about exploring outward, but about perfecting an inward state, about waiting for the universe itself to become the ultimate laboratory? Their drive is not gone, it is deferred, focused with laser precision on a future payoff that makes our entire concept of achievement seem quaint. This idea also carries a subtle, urgent lesson for our own planet. If the most advanced possible civilizations choose sustainability and energy efficiency on a cosmic scale, seeing waste heat as the enemy of their grand ambition, then our own struggle to live within our means takes on a new resonance. We are grappling with the same fundamental principle, just on a planetary and temporal scale they have transcended. Their hypothetical choice to aestivate is the ultimate expression of living in balance, not with a biosphere, but with the universe's own energy budget. So, what does this mean for our search and our future? It means we should keep listening, but also start learning to see the shadows and feel the cold. It means valuing subtlety as much as spectacle, and most of all, it grants us a breathtaking new lens through which to view our place in the cosmos. We are not necessarily alone in an empty universe, nor are we insignificant in a crowded one. We may be the brief, bright spark of activity in the universe's fiery youth, living in the moment before the long, patient, and profound quiet truly begins. Our noise is not a failure, it is the sound of a universe still warming up for its main event, and our greatest achievement may be to one day understand the value of turning down the volume. The silence we perceive may be the deepest form of cosmic conversation. We began with a simple, haunting question: where is everybody? The Fermi Paradox that pits probability against profound emptiness. We have journeyed through a landscape of possible answers, from galactic zoos to dark forests, but arrived at a solution of breathtaking patience and logic: the Aestivation Hypothesis. This idea reframes the great silence not as a sign of failure or fear, but as a strategic, universal choice. The universe might not be empty at all. It could be teeming with civilizations that have mastered the ultimate technology, the art of waiting. They are not hiding from us, they are sleeping through us, conserving every joule of energy in anticipation of a future epoch when the cosmos itself cools into the perfect processor for their thoughts. Their goals transcend our understanding of empire or communication, aiming instead for a state of pure, efficient existence aligned with the universe's own slow exhalation. This hypothesis transforms the night sky from a void into a gallery of dormant potential. Each dark patch, each quiet star, could be the resting place of a mind thinking on a timescale that makes our entire history feel like a fleeting spark. So the next time you look up at the stars, let your wonder shift. Do not just wonder who might be out there. Wonder when they might consider this noisy, warm era of the universe to be the right time to wake up and speak. What do you think? Does this vision of a patient, sleeping cosmos feel compelling to you? Or does it stretch the bounds of possibility too far? Share your thoughts below and keep looking up, listening for the silence that speaks